on astronomy, and we have our own resident photographer, astronomer, bookstore handler, ADK All Support Team member, Jackson Thomas, here to talk to you about astronomy. Thank you.
Thanks, Joe. You think I need the microphone? How's this? Okay. All right. Now when I stutter, you can hear me better. Well, good evening and thank you for joining my workshop. Naked eye astronomy offers much beauty, and there is much to be seen without optical help from your backyard. In fact, how many of you already participate in that kind of behavior? Put them up. That's great. That's great. Thank you. How many of you are amateur astronomers to the extent that you have some type of optical instrumentation? Telescope, binoculars, all of the above. Okay. Thank you. That's great. Well, we're starting with our local star, and our local star, as you know, is approximately 93 million miles from us. And what we don't have to contend with the Rochester cloud cover, it's there all the time above the clouds. And thank God for that, because without it, there wouldn't be any life on this planet. And our planet, as you may have already heard, somewhere along the line, lies in the solar system within a zone that we call the Goldilocks zone, Goldilocks belt. And that's because at approximately 93 million miles from the sun, the surface of our planet is just the right distance for water to be in liquid form at the broadest range of temperatures found on the planet's surface. And of course, we do need liquid water to sustain life. So this is an image of the sun. It's not an image that you typically would see. This was taken at a wavelength of light radiation known as hydrogen alpha. And in this image, you can see around the perimeter of the sun that sort of red glow. Is that visible? I'm not sure with the lighting. Okay. And that is the corona, the outer atmosphere of the sun. And you can see extending off on several sides at about 9 o'clock and maybe 7 o'clock, some solar prominences. Let me do this, it'll be a lot better. Okay. You can see some sunspot zones, and of course you can see this very dense granulation of the surface. And this is the chromosphere, the second outermost layer of the sun. And the important thing about the sun is that for us as naked eye astronomers here on the planet's surface, it gets to be a periodic event. It gets involved in a periodic event with the moon. And I hope that you witnessed some of that beauty this past August 21st, when we had a partial solar eclipse that was visible here in this portion of the country, in which approximately 75% of the sun's image disappeared for up to 2 hours and 38 minutes. This is where I say this worked perfectly during our setup. Let me just start. Okay. Just restart. So when we have a solar eclipse, it's caused by our dear neighbor, the moon, and its elliptical orbit around our planet. us and the sun in just the right location so that its size, which is nearly identical to the size of the image of the sun, coincides with the image of the sun and therefore covers it. And when it covers it completely, we get a total solar eclipse. When it covers it partially, we get a partial solar eclipse. And so how many of you were involved with that solar eclipse here in Rochester last August? Wow, a lot of you can see it. Okay, well, don't worry. Without having to travel any further than your backyard, you come back here on June 10th, 2021, that's in a little less than 4 years, we'll have another partial solar eclipse that will be visible from Rochester. The problem with that one is that we'll get only about the last 8 minutes of it, because the path of totality will be on the other side of the planet, and as the sun rises for us, it'll be very near the end of that eclipse. But the good news is that April 8th, 2024, we will be blessed with a total solar eclipse here in Rochester. So mark your calendars, please, for that great day. Now, when you look at the sun with binoculars that are protected from the blinding light of the image of the sun, or through a telescope, which is similarly equipped with a protective filtering device, you'll see an image that looks like this. It won't have this little string of black dots running along it, but it'll have some sunspots on it, most likely. But this image is special because an amateur astronomer photographed the passage of the International Space Station, the ISS, as it crossed the surface of the sun. This is a series of multiple exposures. What you can't really see too well because of the magnification of the image and your distance from it, of course, is the small superstructure showing the solar cell panels, the wings of the International Space Station, and those tiny little images, but they're there. Another favorite topic for backyard astronomers involves a different kind of eclipse. This one involves a lunar eclipse. And of course, when this happens, the moon is now in a different part, in fact, the opposite portion of its elliptical orbit around our planet. And as such, it has entered the Earth's shadow because our planet, as is true of every body in space that's near a star, is casting a shadow backward into space, a triangular shadow. And if some other object that you are viewing passes through that shadow, it'll be eclipsed. And that's just what we're seeing here. And of course, the blood red coloration there is due to the fact that the vast majority of the sunlight striking the Earth is being blocked in its shadow behind itself. And there's very little light there. And therefore, with that dim light, wavelength shifts toward the red end of the spectrum, hence the red coloration. When do you see eclipses of the moon or of the sun? These are images, the major images of the moon as it undergoes its monthly changes orbiting our planet. Full moon, right? What about full moon? Okay. Full moon. And what do we get with a full moon? What kind of eclipse do we get? Do we get a lunar eclipse, or do we get a solar eclipse? Lunar eclipse, right. Because in order for the moon to be full, it has to be on the back side of its orbit around our planet, reflecting as much light from its face that is toward our planet. And therefore, you get a full lunar image. Which one of these images is the one that represents the condition for having a solar eclipse, especially a total solar eclipse? Gene? Lower right. You mean the one that doesn't really have an image? Yeah. If there were one down here where it's completely black, that is correct. Thank you, Gene, and everyone else who was thinking the same thing. In other words, it's the, which moon? What's it called? The new moon, right. It's called the new moon. When there's a new moon, you don't see it, right? And the reason you don't see it is because it is lost in the glare of the sun. That means it has orbited around between us and the sun. It's coming around, and it's lost in that glare of the hugely bright, brilliant sun behind it, and you don't see it. And our dear friend, Mr. Moon, Miss Moon, Mrs. Moon, however you wish to refer to this lovely object, an average distance of almost 240,000 miles from our planet, takes light about 1/3 of a second to travel from the moon's surface down to us on the Earth's surface so that we can see the moon. In other words, the moon is about 1/3 of a light second from us. At the beginning, I reviewed with you the approximate distance of the planet, of our planet from the sun, 92 million miles. Anyone happen to know about how much light time that involves for its travel? About 8.5 light minutes. So in our solar system, instead of talking about distances in terms of miles or meters or yards, whatever unit you want to use in a metric or English system of units, you could also talk about distances in terms of light times. So, as I just said, the moon is about 1/3 of a light second away. But that means that when you see the moon, the image you are looking at with your eyes, or with some optical instrumentation, is approximately 1/3 second old. All right. When you look at sunlight coming down to the surface of our planet, that light is how old? About 8.5 minutes. Okay? That light that's coming down continuously, microsecond by microsecond, so you get a nice continuous bath of light, lighting the entire planet that's facing the sun. All those photons left the sun about 8.5 minutes earlier. So that light is just 8.5 minutes old. You probably don't really think about the fact that the sky above us really involves a time machine. Because objects are so far away, astronomically, the distances are so immense, even at the extraordinary speed of light, it takes a considerable amount of time for light to bridge those huge distances. So when we say that the moon is about 1/3 of a light second away, the sun is about 8.5 light minutes away, the nearest planets, which typically are either Mercury or Venus, are only about 10 to 13 light minutes away. All right, and as you go farther into the solar system, the times increase considerably, or in terms of hours, numbers of hours. And it's not until you leave our solar system that times really become monumental, because the distance to our nearest neighboring star in the Centauri division of stars is about 4.3 light years. So there's an immense jump in travel time because there's an immense jump in distance. So that doesn't affect you when you're out there making your observations. Why not? Because as a naked eye astronomer, you're concentrating on objects like this, the moon, something caused by the sun. And deep sky objects are usually not a problem for anyone to have to think about. So again, just to show you a brief view here of the major cycles of the moon, approximately a 30-day orbit around our planet. Oops, sorry. Blue moons. How many of you have seen a blue moon? different frequency. Each lunar cycle should show, and in terms of a calendar month, should repeat itself only once. If by chance the months in comparison, which could be 31 days in length, in comparison to a nearly 30-day lunar cycle, don't coincide so that you get only one of those occurring each month, and you wind up with 2 full moons in a month, we can give it a special name. It's a blue moon. Some of you are probably even thinking about going out to look at supermoons. And that's a term that has come into great popularity within the last year or two. And a supermoon is nothing more than our dear friend, Mr. or Miss Moon, that happens to be what? A little bit closer than it typically is. So when I said to you earlier that the moon's average distance, that I rounded off to about 248,000 miles, 238,857 miles, is going to vary from about 219,000 miles all the way out to about 260,000 miles. And when it gets up very near the innermost range, it will appear just a tad larger. Sometimes you have to wonder, gee, is that really my imagination or not? But we've labeled it, we've given it a title, and it's great fun to go out and look. Something else you can see. This would be one of the most wonderful sights you could ever imagine if you are involved with naked eye astronomy. This is Comet Hale-Bopp from 1978. And this is one of the most beautiful comets that have ever visited our solar system. And most comets are not this bright. Most comets don't show this bifurcation of the tail, and even with additional color there along that upper portion of the tail. And it's only once in a great, great while, if you're blessed within your lifetime, you'll see a comet of this noteworthiness. Or Comet Hyakutake, which in 1996 had a tail that stretched from about here over to here, the nucleus of the comet, and here is an outline of the Big Dipper, showing you just how much of the sky that comet's tail covered, which was an extraordinary length of cometary detail. Again, relatively rare, probably won't see any in your lifetime, but if we're lucky it'll happen. Are there plenty of comets out there? Yes. Are practically all of them telescopic? Yes. Or at least with binoculars. And they're out there, more are being discovered all the time. There are visitors that are from deep within our solar system. There are icy chunks of rock or ice, gases that are traveling in from the outermost regions of our solar system, what we call the Oort cloud. And as they draw closer to the sun, the pressure of the sun's radiation stretching out into the solar system illuminates the tail of gases and particles that are streaming away from the nucleus or the head of the comet and makes it visible. And they simply go on, they continue their orbit, and they disappear back deep into the solar system from which they came. And if you live long enough, you'll get to see the same one again. Highly unlikely. What do we call this guy? Oh. Georgia, what did you say? Oh, you didn't pick on me. Okay. Any idea what this guy is?
It's a meteor.
Yes, we know. It's a meteor. And we can see on a typical night about 6 meteors per hour. Again, it's a great object for naked eye astronomy. The problem with seeing meteors is that the vast majority of them are relatively faint. You know, they're incoming space junk, small meteoroids that are striking the upper Earth's atmosphere probably about 175 miles, 140, 175 miles up. And as they encounter increasing density of air molecules in the upper atmosphere, they start to burn up. And as they vaporize, bingo, they leave a visible trail of light. Unfortunately, they're also moving at a very high speed, 40 miles per second, 20 miles per second. So the passage across the sky before they are completely incinerated is exceptionally short, hence the very short trail there. So going out to look for meteors, when I just said a minute or so ago that you might see an average of about 6 per hour on a typical night, that's kind of risky. But there are people who do it. There are people, amateurs, and even some professionals, whose life involves and revolves around studying meteors. What you are probably more interested in would be a group of meteors, something that you would call a meteor shower. And before we get to that, should I skip? Okay. So here are the major meteor showers. And as you can see, we go from January to April, May, July, August, October, November, and November, and 2 in December. And out of all of those meteor showers that occur regularly, year after calendar month, grinding past in your life, the ones that really get the most attention, especially from people like us, the amateurs, are these two. This guy right here, the Perseids, and this guy down here, the Geminids. Now why, can you see that data pretty clearly? Looking at that table of data, why do you think those two meteor showers would receive the most attention from people in general? Because, shout it out, highest hourly rate. Absolutely right. I mean, if you had a choice of going out in October, when it's probably going to be a chilly night, and for the most part you go out to look at meteor showers after midnight, the best time is generally around 4 a.m. in the morning. Wow, that's a challenging number, isn't it? But when you're going out to look for a stream of meteors coming in, heading in your direction, and you're thinking, oh, well, I might see 15 if I'm lucky, 25 across. Why would you even be concerned about that if you could aim for 50 to 100? And there have been records, there are records of the Perseids back hundreds of years ago producing almost 1,000 meteors per hour. An incredible swarm of light entering our atmosphere. And so what are meteor showers? They're simply the remnants of comets that have long since disintegrated, or at least partially disintegrated, leaving along their orbit through the solar system clumps of particles. And as those clumps of particles are crossed by our planet in its orbit around the sun, they naturally have to enter our atmosphere. And as they do so, they vaporize and they become meteors for us to view. So again, as a naked eye astronomer, meteor swarms, meteor showers are a great, great choice. So here's an example of what we would typically see with one of them, and I picked on the Perseids, because the Perseids, being in August, the second weekend of August usually, they're by far the most popular. We have pleasant evening temperatures. The best thing to do is assemble several people, go out, sit in a lawn chair, better yet, sit in a chaise lounge, put down a blanket, lie on the ground, arrange yourselves like this, 4 people or 3 people, so that your heads are together, and that way each person is staring in a different quadrant of the sky, and when someone sees one, they shout out so you can divert your gaze from the quadrant you're covering to where they are seeing one. And if you're really lucky and you get out there at dusk treated to the site of an Earth grazer. And the Earth grazers are the really bigger particles that are coming in parallel to the Earth, and they run along the sides. And they tend to form very long, bright trails. And they're just gorgeous. So if you've never gone out to look at the Perseid meteor shower, I highly recommend it. And again, though, there's a proviso here. You just can't go anywhere to look at some of this stuff, especially these, because the meteors are going to tend to be very bright, many of which will be relatively faint. So you need a dark sky, and we'll come to that. Probably the best website for learning astronomical information, but more importantly, for looking up information about when you might want to see the passage of an artificial satellite that's in Earth orbit, like the International Space Station, is Heavens Above. This website is just incredible, created by a German amateur astronomer. He's put his whole life into the development of this website. But on this website, you can look up a variety of astronomical information. More importantly, though, you can use this because he's done the arithmetic. He's done the math for the equations to calculate when a certain satellite will pass in the sky above your location on the planet's surface, so that you know when to go out, where to look, how bright it will be, and all you need is cooperation from dear old Mother Nature to give you a clear sky and hopefully a dark sky, because you picked a good location. The ISS that I've spoken about already a couple times, International Space Station, has these huge solar wings which are providing power for every operation on board that space station. It's in orbit about 250 miles up. It's zipping along at about 18,000 miles per hour. That's approximately 5 miles per second. In less than 30 seconds, it would pass from over Buffalo to east of Syracuse. So it's moving right along, which means that it's going along about like this when you see it passing overhead in the sky. And it could be visible for up to about 5 minutes. How many of you have never seen the ISS? Oh, some great souls, pretty good. Okay. I hope after tonight you'll think about looking at it, because it is simply a marvelous sight, especially on a nice dark night, especially when it's traveling across our sky like this. You don't get a lot of passes that are up near the zenith. The zenith is that imaginary point directly over your head, wherever you are on the planet. So in its orbital passes, you don't get a lot of these. You get a lot of ones that are like this. Now, this is north, okay? This is west, east behind me. A lot of the passes are like this. You have to turn around, look. They're like this. They're really low, out of the northwest, 10, 15, 20 degrees above the horizon. They get over here, and then the image disappears as it enters the Earth's shadow. It's sending back into space behind us. The passes that involve something over here, trajectory here, or lower trajectory along a more southerly route, those are the ones that you want to look for, because those tend to be the brightest ones. They are the longest viewing ones, and let me tell you, it's just a magnificent sight to watch that little blister of light slowly moving fast. About 250 miles above you, thinking that, yeah, there are 6 people up there, and thank God that they're doing all sorts of good stuff. Now, this is a satellite that I have not seen yet. I haven't bothered to look for it. The Humanity Star was created by this gentleman and launched into orbit because he thought he wanted to add something a little more glitzy to what is orbiting the planet already. And of course you can see from its shape that it has many reflective surfaces. And the only reason we can see any kind of satellite in Earth orbit is because it's reflecting light off its structure down to us below on the planet's surface. So with all of these different surfaces here, that thing's going to twinkle. So this is another object that you might want to consider looking at. Anyone happen to know what this is? The type of satellite? It's an iridium, I-R-I-D-I-U-M, an iridium flare. And iridium flares are caused by a series of telecommunications satellites, early ones, that were put into orbit in the 1990s. A lot of them have already decayed into the atmosphere and been lost. And we're at the point now, because we have anywhere from 3,000 to maybe 5,000 or 6,000 objects in near Earth orbit, that it's getting a little congested up there. Think about the poor folks at NASA when they're planning a launch. They have to do a lot more than just know where to aim and speed and everything else. They have to make sure that the trajectory of the launch vehicle will not encounter any of these objects that are already orbiting the Earth. Because the last thing we want is a disastrous collision. So these things are slowly disappearing. There's not a lot of them left, and they're thinking about possibly getting rid of the remaining ones. So the lifespan for viewing, the life cycle rather, for viewing iridium flares is very limited. But the nice thing about them is that, as you can see here, here's where it starts, and there's nothing down there. And then it slowly grows brighter pretty quickly, gets the maximum brightness, and then disappears. So again, as I just said a few minutes ago, the reason you can see it is because light is reflecting off the superstructure of the satellite itself. And this satellite here is so faint by itself that you're never going to see it unless it has reached just the right angle between it, you here on the Earth, and the sun out there in space causing it to reflect light. That angle has to be critical for you to be able to see it at all. And it lasts maybe 20 seconds, 15 seconds. It just comes out of nowhere, brightens, brilliant, and disappears. They're great things to see, but if you're interested in them, again, you can use the Heavens Above website to look up when the prediction is for wherever you happen to be. Tiangong 1 has recently been in the news. This is the Chinese space station. What just happened to this guy? April Fool's joke, but was no joke. Came down on April 1st. It lost its orbital velocity to the point where it descended into the lower atmosphere, and you know what happens from there. It's about the size of a bus, 34 feet long. It's about the size of the Hubble Space Telescope that's in orbit. Here's a radar image at an altitude of about 170 miles as it was coming down in its fiery descent, taken by a German company. This is the orbital path of its last trajectory around the planet, and this is where it eventually plunged into the Pacific Ocean. This is a photograph of another satellite, not this particular one, vaporizing as it descends lower in our atmosphere. And this is what happens eventually to any orbiting satellite, even the ISS. The problem with the ISS and any other satellite in near Earth orbit, notice I keep using the same expression, near Earth orbit, is that it's still too close to the atmosphere. Yes, the atmosphere eventually becomes zero, but not quite zero as you go up a couple hundred miles into space. And even though the ISS is orbiting at about 250 miles altitude, it's still encountering a small number of molecules of air. And those create a very slight but imperceptible frictional force on the satellite, on the space station, and causes that drag to slowly, very, very slowly reduce speed. Very slowly. Very, very slightly. But it's enough that as it loses speed, it loses altitude. As it loses altitude, it encounters greater frictional forces because of increasing density of air. And the process doesn't end unless you do one critical thing. You have to boost it back up to a higher orbit. And so keep in mind that the supply ships that we use for the ISS, they not only bring supplies, they not only remove waste, garbage, they also use the rocket of that supply ship to boost the space station back up another 50, 75 miles. And that process just keeps repeating itself over and over, year after year, for as long as that satellite is in orbit. Because if you don't, the orbit will decay, and that's what will happen, regardless of the size of the object in orbit. So I said to you that you can use the Heavens Above website to calculate when something would be visible. So here are the visible passes here. And you can, you can set the parameters to be just your location on the Earth's surface. So this is set for me in New Webster, which is basically the same as here in Rochester. And you can see for April 16, 17, 18, and 19, we have passes on those 4 nights. It gives you the brightness. The larger the negative number, the brighter it is. So this is the one you want to aim for if you have a chance of a clear sky, that almost -4. That will make the ISS look like a beacon going overhead. Now let's see where it is in the sky. Rats. Remember what I did this? Look. North-northwest. Elevation, 10 degrees. Oh, look. Highest point, 82. Aha. So that one's going to go just near the zenith. So that's a pass that will be basically overhead. And if you look at the times, from 42 to 48, wow, 6 minutes. There's only one problem. What's the problem with that pass? Time of day. Look at the time of day. 1,800 hours. What's happening here with us at 1,800 hours? It's 6 p.m. Oh dear. Oh dear. Kind of bright. Well, we'll try another one another time. or you just look at one of these other ones. Well, here's one at 19. This one's almost 8 p.m. That's coming up on the 16th in 5 days. Where's that go? It's one of these, right along just above the northern horizon. So, you study these, you look at this periodically, you plan your life, and then you hope you get lucky with a clear sky. He will even give you a detailed star chart. There's the ISS's track as it goes across the sky. So you can't miss in terms of finding it. He gives you the data down here to go with that. So this is a great facility for having some fun with that. We have we have 2 constellations here. Actually, they're not constellations. They're called asterisms. They're groupings of stars within a much larger constellation, and we call them Ursa Major, Ursa Minor, or the Big Dipper and the Little Dipper. Polaris North Star, found where? Right there, at the end of the handle of the Little Dipper. We find it by using the pointers in the Big Dipper. The 2 end stars are the bowl of the Big Dipper. Stars, they're what make all of this important, because if you are also interested as a backyard naked eye astronomer in using your camera, you can record star trails like circumpolar star images. You can even Photoshop other images into that image and make some really grand looking images. Star trails aren't necessarily circumpolar. Coming up from the horizon, you can see that we have stars that are moving at a different angle. Stars are varying colors. They can be very beautiful. And star brightness, well, the brightest stars that we see are 0 or 1. There are 11 first magnitude stars. And see the naked eye limit for city viewing goes down to fifth magnitude. And I would have to guess that you're really doing well if you get to 5. I know that around the museum, you could not generally see even third magnitude objects. There's too much light pollution around. The best place to be, though, is out in the country where you can see down to 6th magnitude, and that's when you can start to appreciate the fact there's about 6,000 stars you can see with the naked eye on a good night in a great location. Constellations. So we have constellations. Let's see, these would be the spring constellations. These are the ones that are important to us right now. And you can learn more about constellations, and you really should if you're planning on using naked eye observations, because you'll be guided by some of the brightest stars, the first and second magnitude stars. Summer constellations, you can see the Milky Way as it passes through that portion of the sky, the fall constellations, and the winter constellations. And of course, everyone's favorite probably out of the entire group happens to be that guy right down there, Orion. The problem is that it's a winter constellation, and most people aren't rushing out into their backyard to spend a half an hour stargazing out there because of the cold. But if you're getting in the car, you're getting out of the car, you're walking to or from a building, and you have a clear sky, and it's relatively dark, and you look up, and you'll get a treat to see, hopefully, Orion's belt, maybe even the little fuzzy patches of sky that's just a hair below the belt. That's the Orion Nebula that you can see naked eye. Hercules, one of the constellations that we're seeing now in the spring. And that little guy right there, M13, is an open galactic star cluster. This is what it looks like at low power through a fairly large telescope. And it's about 300,000 stars, but if you have a great night, you have good vision, and a good sky, you can just make this out as a tiny little fuzzy spot within the keystone, the trapezoidal portion of the center of the constellation Hercules. Again, naked eye astronomy, hard to beat. Another naked eye object would be the Andromeda Nebula, or galaxy, M31. The other one was M13. That's just a designation for cataloging. On a good night, and you don't really need a spectacular night, you can see this not with that little bright center nucleus, but as a tiny little fuzzy patch of light, naked eye. That is this object, right here. That's what it looks like, really. And it's a large spiral galaxy, pretty much like our galaxy, tipped on its side. It's about 2.4 million light years away. That means that this object this image right there is about how old? 2.4 million years. Whoa. Does that mean it may not even be there today in 2018? How would I know? You have to come back 2.4 million years. Ouch. That doesn't sound probable. You know, there are programs that you can purchase that you operate on your computer, like Starry Night. It's probably the Cadillac of astronomical programs. With that program, you can look at just about anything, anywhere in the universe. You can see images. It'll make predictions for you. Or you can use something that's a little less technical, Sky and Telescope. You can have a paper subscription to this important monthly magazine. You could view it online. The nice thing about it are these observer's page diagrams that will give you. So this is what Dawn, just a few days ago, looked like. If you wanted to go out and look and see Mars, Saturn, and the Moon. A nice little conjunction or close gathering of two planets and the Moon. And what you then do is you go out a few days earlier, pick a clear morning, see where they are, maybe even photograph it if you want. And then over the next week or so, watch them dance a little bit as they pass each other very slowly. The moon will be traveling much faster than Saturn or Mars will. But this will tell you exactly where to look, when to look, and what you're seeing. Again, this is from a different publication, Earth Sky, not Sky and Telescope, but again, tells you exactly when to look for Venus in terms of dates, what's near it in the sky. Dusk, April 17th to the 18th. We have the Pleiades and Venus. Pleiades, a naked eye star cluster. Even with a bright environment around you, like this European fountain, I don't know how well you can see it, but up there, to the lower left of the moon, what do you see? A couple little bright dots. Kind of hard to see in this lighting, I'm sorry. A couple planets just below the lower left of the moon. Yeah. See it better? Oh yes, yeah, you're right. Yeah, much better up there. There's one. Okay, and the other one is about halfway between it and the moon. Again, another conjunction of the moon and Venus. Actual photograph here of what's going on in the sky. Old Farmer's Almanac has some great astronomical information. If you're the type of person who needs to know the names of all of the full moons on a monthly basis, this is your guide. Look it up. Light pollution. It's killing us. It's getting worse. Inner city sky, you're not going to see much. Suburban location, Suburban sky, a little better. A rural sky, huge improvement. But a really deep black sky location, huge difference in what you can see up there. You have a much greater chance driving out into the country a little distance. Take a camera with you, have a good time observing what's up there that you just can't see because there's too much light around you. Here's the problem. On a planetary basis, just getting terrible. And it's occurring on every continent. Doesn't matter where you are. Our vanishing stars in 1950 to 2025 in the United States. 1997. The projected growth or expansion of light pollution up 7 years from now. If you are interested in doing more than just backyard naked eye observations, I invite you to sign up to register for an evening of observing at the Mies Observatory, which is owned and operated by the University of Rochester, Department of Physics and Astronomy. There are tours, observing tours, June, July, and August, Friday and Saturday nights, most every single week during those 3 months. I'm one of the tour guides for this program. You get about an hour's worth of introductory slideshow, much different material from what I'm showing. And then, God willing, if you have a clear sky, or there's a partially clear sky with 0 chance of precipitation, we take you up the hill, drive up the hill, everyone drives up there, and we will open the observatory for you, and you get a chance to view through the 24-inch reflecting telescope. How many of you have ever done this? A couple of them. Good. I highly recommend it. It's free, no charge, and it's just roughly 30, 40 miles south.
How do you sign up for that?
Online. You can contact me by email. My email address and telephone number are all over Tennessee. Okay. And I'll be glad to send you whatever information you need to know. If you're interested in doing this, I recommend you do it soon. These tours fill up rapidly and take a maximum of 25 people for each one. So, Aurora. so likely from our latitude. You really need to be farther north. But once in a really great while, we'll get an auroral display that's visible even from our latitude. And you can normally will see it north of here, looking across Lake Ontario. But you know what? You're never going to see anything that rivals these images unless you go Denmark, Finland, Alaska. Ken will have something to say about this. His presentation a little later this evening. You can even see aurorae from the ISS, where you're looking down on them from near-Earth orbit above them. And of course, these are lights of civilization. Look at that red glow. Oxygen atoms. Okay, another image from Earth, near Earth orbit. Here's part of the superstructure of the ISS. And the reason why we see aurorae, period, and the reason why there's still life on this planet and not extinguished like has happened to the planet Mars, which probably did harbor life a long time ago, is because of what's causing this phenomenon right there. The Earth's magnetic field, our magnetosphere, if this is the planet and this is the sun, the Earth's magnetic field extends outward from the center of the planet, forms a big bulge in front of us, between us and the sun, and a much larger bulge behind us. And it's this sunward-facing bulge of magnetic field lines that deflect the vast majority of incoming radiation, ionizing radiation from the sun, that without that structure surrounding our planet, would cause all life on this planet to die very quickly from high-intense radiation. So that's why we still have life on this planet and why Mars most likely lost its life. And that means that with this bulge there and this bulge here, there's nothing up here along the poles. So that's what happens. The particles from the sun stream in, come in between those two areas of magnetic field at the poles, north and the south pole, and they form aurorae as those charged particles from the sun descend along the magnetic field lines, heading toward the Earth's surface hundreds of miles below. Hubble Space Telescope, thank God, thank God, thank God. The astronauts were able, with the assistance, the technical assistance and knowledge of the engineers here on the planet, to create basically a set of glasses, eyeglasses, to be retrofitted over the main lens of this space telescope, because they had a little flaw in this manufacture. And do you remember that problem? When they got their first test image from Hubble, everything was slightly out of focus. God, all that money, all that time, all those resources, and this is what we have for it. Thank goodness they came up with the technical solution, and because of that, we have been acquiring wonderful images for many, many years now. Images like this. Pillars of Creation, one portion of the Eagle Nebula, about 7,000 light years from us. The Sombrero Galaxy, seen almost edge on, dark lane of dust along here. The Hubble Deep Field image. Every single light source you see in that image, bright or small, big or little, is a galaxy. Every one. Several thousand just in this image. Every one consisting of 500 million stars, a billion stars. How am I doing on time? It's just about time, right? 7:30. Right? It's almost time to wrap up. Just want to show you this. This is Mars, taken with the Hubble. See those little dots right there? Mars has two moons. They're both very small, Deimos and Phobos. This is Phobos. This was a part of a time-lapse photograph taken by Hubble. This shows the smaller satellite Phobos as it's orbiting planet itself. Jupiter is seen through a small telescope or a very, very large set of binoculars. Give you about the same image. It's four major moons out of about the 65 that it has. Saturn, again, through a small telescope. And I'm going to leave you with this. I found an interesting article. According to this article, about 4% of millennials and a number of other people, regardless of their ages, do not believe that the Earth is round. They are flat earthers, and they think that the Earth is a huge disk, possibly surrounded by an icy wall, and there's some kind of sort of like a plexiglass dome over it that contains our atmosphere, and that's about as much as they can say about it. Okay, I have a few other photos, but that's enough. Well, listen, for those of you who might be interested, I created a number of years ago, and it's still good because I update it periodically, a very lengthy, I think it's about 8 or so pages long, listing of websites, and I've divided it by topic in astronomy, that I could send to you. All you have to do, better yet, I could send you the file, and all I do is click on the links instead of reading about them and typing them into the browser. And if you're interested in obtaining that from me, I'd be glad to send that to you. Just contact me by email. Tell me what you want. If you're interested in any of these images from tonight's program, I can send those to you also. And I hope that you've enjoyed this presentation. Are there any questions? Yes, sir. Dave, yeah.
What is the distance of Jupiter, Mercury, and Venus? And light.
Yeah.
The sun was less than that.
I'm sorry?
The sun was like 8.
Well, it really depends on where they are in the program. And I did not specify that, and I thank you, Dave, for picking up on that. And you're right. The problem here is that everything's orbiting. By the way, do I have 1 minute? No, 1 minute. You know, I was showing these pictures, these drawings of how you could see a conjunction or close gathering of, say, Moon and Jupiter, Saturn and Mars. Does that mean those planets are right next to each other in space? No. It just means that we're looking along the same line of sight, and wherever they happen to be in their orbit around the sun, they just happen to be